Okay, may I take this opportunity to welcome you to today's lecture. That is lecture 3 on the structure of atoms. Okay, so in lecture 3 we are going to look at classification of atoms. Of course, atoms can be classified as either isotopes, isotones, isobars, or isomers. Of course, so atoms of different elements can be classified as shown here, whereby the isotopes have same atomic atomic number and different mass number. And then isobars, they have same mass number and different atomic number. And then we have isotones that have got same number of neutrons, the different atomic number and different mass number, different atomic number. Then we have the isomers, then we have the mirror nucleus, which we're going to look at. So let's start with isotopes. Of course, isotopes are atoms that have got same number of protons but different number of neutrons. And therefore, because they're different number of neutrons, then it means that the mass number will also be different. Therefore, we say same atomic number but different mass number. That is Z and A. Example, we can talk of carbon 12, carbon 13, we can talk of carbon 14. So those are the isotopes. So they have same number, same atomic number, but different mass number. So the same number of protons, but different number of neutrons, which brings about a difference in the mass number. So we have the protons, which are green in color. We have the neutrons that are red in color. So you can see here the protons are the same, but the neutrons are different. Therefore, they are bringing about different mass number. So example of isotopes, we can talk of the isotope of silicon, that's silicon-28, silicon-29, silicon-30, silicon-32. You can see they have got same atomic number 14, but different mass numbers. Okay, isobars, on the other hand, are atoms that have got the same number of nucleons. That is, when you talk of nucleons, we are talking about the mass number. That's the number of protons and the number of neutrons added together. But they have a different number of protons, on the other hand, and also neutrons. So therefore, they have the same atomic number, but different mass number. So examples, we can talk of nitrogen 17, oxygen 17, and fluorine 17. You find that they have got the same mass number of 17, but they have got different atomic number, 7, 8, and 9. So the isobars, they have same mass number, but different atomic number. So the number of neutrons keeps on varying accordingly. So you can see here, we have the protons that are green and the neutrons that are red. So here we have the protons that are different, then the neutrons are also different. But you see that the mass number will always be the same. Like for here, we have oxygen 16 and nitrogen 16. So oxygen has with 16 and nitrogen 16 with same mass number but different atomic number of 8 and 9. 8 and 7, I mean. Isotones, on the other hand, are atoms that have got same number of neutrons but different number of protons. So we have got same mass number minus atomic number, but different number of protons, of course. Example, we talk of chlorine 37, we talk of potassium 39, we talk of calcium 40. You can see they have got different mass numbers. At the same time, they also have got different atomic number. Therefore, when you look at 37 minus 17, you get 20. 39 minus 20, you get 20. 40 minus 20, you get 20 still. So it means that they have the same number of neutrons but different protons. As you can see here, we have same number of neutrons at 2, 2, but the protons here is 2, here is 1, so they're different, of course. So isomers, on the other hand, they are atoms that have got same number of protons and neutrons, that is the same atomic number, mass number, but different nuclear energy states. They possess different nuclear energy states, of course. Like, for example, because of technetium, which is in metastable state, and technetium that is just a stable state. On the other hand, we also have the mirror nuclei, which we are going to look at our next lecture. Otherwise,